Dear students, this is Debaprasad Mukhopadhyay, Assistant Professor of Sri Ramakrishna Institute of Science and Technology, Department of Mechanical Engineering, bringing you this lecture on rolling and extrusion as per the syllabus of Manufacturing Process 1, second year, first semester. Rolling. Introduction. Practically all metals which are not used in cast form are reduced to some standard shapes for subsequent processing. Manufacturing companies producing metals supply metals in the form of ingots, which are obtained by casting a liquid metal into a square cross section. This is actually the material that is being supplied from the steel plant. They are called slab, which is actually 500 to 1800 millimeter wide and 50 to 300 millimeter thick. Then we have billets, which has got a cross-sectional area of 40 to 150 square millimeter and length as per requirement. And then blooms, which are larger ones, which has got 150 to 400 square millimeter cross-section. Sometimes continuous casting methods are also used to cast the liquid metal into slabs, billets or blooms. These shapes are further processed through hot rolling, forging or extrusion to produce materials in standard form such as plates, sheets, rods, tubes and structural sections. You can see in this picture that in hot rolling the ingot slab is rolled and they are actually producing steels and plates, and at the final stage through cold rolling thin sheets are produced. Billets, which has got a little smaller section than bloom, they are actually transformed into bars and rods, and blooms, which has got the largest cross-sectional area, are transformed into structural sections like angles, channels, beams and rails. These are the shapes of the bloom, billet and slab that come out of the steel plant. Bloom, they are converted through rolling mill by passing through the roll pass into shapes like beams, rails, channels, angles, etc. Slab is converted to plates and sheets or thin sheet metals which are supplied in the coiled forms, and billets are converted into bars and rods. These are very important. Please make note of these basic materials. In rolling, what happens, there are two rolls rotating in the opposite direction and the direction of workflow is shown here. The workpiece thickness here is reduced while passing through the roll gap. The grain changes while the change of the grain sizes while passing through the rolls in hot condition is shown in this particular photograph. You see the crystal size is higher before they enter the roll and it becomes elongated while they pass through the roll. Here, if T0 is the thickness at the input, T1, which is a lower thickness, it comes out after the rolling operation. The different grain size changes are shown in this diagram. Now, salient points about rolling. Rolling is the most extensively used metal forming process and its share is roughly 90%. That means 90% of the steel materials in use are produced by the process of rolling. It is so much important. The material to be rolled is drawn by means of friction into the two revolving roll gap. The compressive forces applied by the rolls reduce the thickness of the material or changes its cross-sectional area. The geometry of the product depends on the contour of the roll gap or roll pass. Roll materials are cast iron, cast steel and forged steel, because of high strength and wear resistance requirements. Hot rolls are generally rough so that they can bite on the work, and cold rolls are ground and polished for good finish. Now here we are showing the progressive rolling of a 12 millimeter rod from 100 by 100 millimeter billet in progressive rolling. You see now 100 by 100 millimeter billet has got a cross section like this. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. After 10 stages, it becomes a wear. These are all in hot condition. The roll pass that is designed in this form, the gap between the two rolls takes this form so that the output material on the other side takes the shape. There are various types of rolls in use. 2 high roll where there are 2 rolls, 3 high rolls where there are 3 rolls and the material is fed into, from one set of roll it is fed into the other set of roll so that the thickness is reduced in 2 stages. This is the 4 high roll where actually two working rolls are at the center and the 2 backup rolls, they put the pressure on the material. Here the main rolls are always in contact with the hot metal that will reduce the life of the roll. Here the main rolls are smaller in size and the replacement cost will be less. The backup rolls, they are not in touch with the hot metal. This particular arrangement is a modification of the 4 high roll. Instead of 2 backup rolls, here we have got 4 backup rolls so that the pressure can be maintained better. This is the tandem roll where progressively the gap between the 2 rolls are reduced from stage 1 to stage 2 to stage 3 and the thickness also gets progressively reduced. There are other deformation processes like thread rolling, then rolling of a ring where edging rolls, then idler roll and main rolls are used so that a ring can be formed. Then we will go into the process of direct and indirect extrusion. In rolling, we are passing the hot material through rolls. In extrusion, we are putting the red hot billet in plastic condition in a chamber. And with the help of a ram, this material is pushed out through the die, and on the other side of the die, the extruded material comes out. It takes the shape of the die opening. If the die opening is elliptical, then the material at the output will be elliptical. This is called direct extrusion, where the ram is pushing the material on this side and material comes out from the same side, in the same direction. In indirect extrusion, the end of the chamber, the extrusion chamber is closed, and the die is placed here, and there is a hollow ram that pushes the die itself on the billet. And if the pressure is on this side, the plastic material after extrusion it comes out from the opposite side. This is called indirect extrusion. In direct extrusion, metal flows in the same direction as that of the ram. Because of the relative motion between the heated billet and the chamber walls, friction is severe and is reduced by using molten glass or a lubricant in case of steels at higher temperatures. At lower temperatures, oils or graphite powder is used for lubrication. The friction inside the chamber is reduced. In indirect extrusion process, metal flows in the opposite direction of the ram. It is more efficient since it reduces friction because there is no friction of the hot metal with the chamber. Friction reduces considerably, but this process is not extensively used. It restricts the length of the extruded component. Very long components cannot be extruded by this process. We can just briefly say about the drawing process. Drawing is actually mostly used for wire drawing mills. The material is pulled through the die from one side. That is why it is called drawn. It's pulled on this side, and the section reduces through when the material goes through the die. Large quantities of wires, rods, tubes, and other sections are produced by drawing process, which is basically a cold working process. In this process, the material is pulled through a die in order to reduce the desired shape and size. I think now we have come to a stage where we will see some videos of the rolling operation.
This is a Dalarna University production.
This film will give you, as a student, an overview of the processes within a hot rolling mill. The film is made in collaboration with SSAB in Borlänge. Here, the steel material is processed plastically at very high temperatures. Rotating rolls reduce the thickness of the material and produce long strips that can be used for manufacturing products such as steel plates. We will be going through the various stages of the hot rolling process.
These are the hot rolling mills.
Each stage requires knowledge and experience to ensure a high-quality product.
This is the slab. This is a slab.
The material is heated in the reheating furnace,
It is being
rolled
fed
in the
into the
roughing
furnace.
mill, coil boxed, roll in a finishing mill, cooled and coiled.
The sheet metal
Before
is
the
collected
slab
in the
can be
form of
processed, it must be heated. The slab is continuously cast and has the dimensions required for the final product of a correct weight, width,
These are the
and
slabs.
thickness. These furnaces heat the material to about 1200 degrees centigrade. Two walking beam furnaces feed the material through the oven.
These are the walking beam furnaces.
The heating is especially important as it affects the properties of the material. If the material is not sufficiently heated, incorrect material properties will arise. This is due to oxides and nitrates failing to dissolve. During the heating process and the transport to the roughing mill, the hot material reacts to the oxygen in the air, and a mill scale consisting of oxide is formed on the surface. If the oxide layer remains on the material during rolling, the layer risks being rolled into the steel material, adversely affecting the surface quality of the final product. The material must undergo a mill scale cleansing before rolling. In order to cleanse the surface, water is sprayed at high pressure, 160 bar.
Actually, what is being told here, that actually the red hot material, when it comes with the contact with oxygen, it forms oxide scales. These are very damaging to the steel because during further rolling process, these oxides will go inside the material. So with a high pressure water jet, the scales are being cleaned in here.
After the material has undergone a surface cleansing, it's sent to the roughing mill. Here, the material is rolled from its original thickness of 22 centimeters down to about 3 centimeters. This is a very significant reduction. At this roughing mill, a powerful 4-high rolling mill is used. That is, 2 backup rolls and 2 smaller working rolls. The backup rolls are often cast steel rolls. The working rolls must have very smooth surfaces and tolerate high temperatures and wear, as they are in direct contact with the material. This particular material is rolled with 5 passes, where 1 pass means that the material...
you see the material thickness is reduced from 220 millimeter to 30 millimeter, and by through five stages this material thickness is getting reduced. That's what the process is being
material
described.
passes through the rolls once. The material is surface cleansed several times during the roughing mill process to remove any new traces of mill scale. In order to control the width of the material, vertical rolls are used. The material is now called transfer bars. After the roughing mill, the transfer bar is rolled up in a coil box. The coil box's primary purpose is to save space, but when inside the coil box, a temperature equalization also occurs. The temperature difference between the ends of the material is minimized as the transfer bar is coiled together. When the transfer bar is removed from the coil box, it has a temperature of about 1050 degrees centigrade. The ends of the transfer bar are cut off, and the bar undergoes further mill scale removal. After this, it's time for the next stage, the finishing mill. This mill consists of 6 stands in the shape of 4 high rolling mills. Here, the transfer bars, now called strips, are rolled into a
These are all 4 high rolling mills. In 5-6 stages are there.
thickness of between 16 and 1.8 millimeters. Between the rolls we see an uplooper, which measures and controls, amongst other things, the line speed and the strip tension. The swinging motion that can be observed is when the uplooper is adjusting itself.
This is an adjusting roll.
In order to control the profile and the flatness of the strips, the working rolls are horizontally adjustable. The first stands control the profile, and in the later stands the flatness is controlled. It's very important to have a correct strip profile and flatness before any post-processing starts.
So in 5
The
stages,
cooling rate
thickness
is
is
adapted
getting
to each
reduced.
strip to produce the appropriate microstructure and material properties of the end product. When the strip has passed through the cooling section, it's coiled in. The temperature during coiling varies between 150 and 750 degrees centigrade, depending on the properties assigned to the material. After coiling and the subsequent cooling, the strip can be sold directly to the customer or undergo additional processing stages, for instance, cold rolling.
Yeah. The additional processing may be, annealing also, and there can be further cold rolling to reduce further thickness. So we come to the end of this video. I hope the process of rolling and extrusion has been made clear to you. Thank you.